Hi, everyone. We'll go ahead and get started now that we're at 12:45. We're the first team presenting today. We're team 2302, sponsored by Astronics. And the software that we developed for them is an ARINC 665 compliant packaging library. Here's some information about our team. I'm Colin Ennis.
I'm Cahill Mullen.
I'm Harry Rudolph. I'm Jesper. I'm Terrence Salem.
And our advisor for the past 3 quarters has been Professor Yang. Here's some information about how we structured our team. So we're an Agile and Scrum team. So we're Agile, meaning we adhere to Agile values, things like valuing working software over comprehensive documentation and the other Agile values. We're also a Scrum team, so we're doing sprint iterations. We did 2-week sprint iterations for the past couple of quarters, meaning that we focused our work during these 2 weeks, and then in between the 2-week sprints, we're planning for the next sprint. We did bi-weekly meetings with our sponsor and bi-weekly meetings with our advisor, and we kind of structured our sprints around these meetings so that we have things to deliver to them, and any questions that we gained over the sprint, we could ask them at the end of that sprint during that meeting. So we're sponsored by Astronics. We're specifically sponsored by the AES division of Astronics, which stands for Advanced Electronic Systems. They manufacture hardware and software solutions for the aerospace industry. They work on commercial, business, and military aircraft, and they are most well known for their electronic and lighting integration systems. One example they gave to us is they specifically made the component that you plug your iPhone charger into on the airplane in the seat in front of you. That is one thing that Astronics makes for the aerospace industry. We have 3 main points of contact that we've been interchanging information with at Astronics. We've got Doug Brown is here today, Chief Software Engineer. Jerry Ortoli is a software engineer, and Carla Coleon is another software engineer.
And here's some background into our project and as to why we had this project. So currently, Astronics AES is using a very old third-party program for over the past decade to help package software onto airplanes. While this software works perfectly fine right now, with growing concerns for security and new standards coming out, this lack of ability to modify the third-party program could stand in the way of meeting their customers' needs. So through this, we have 3 new goals. We have 3 goals for our project. So firstly, we wanted to provide a new extensible library and API. Through this library and API, any changes that need to be made to meet new standards and new requirements could be made easily and added onto this library. A key part of this library was that it should have the key functionality of this old third-party program, in that it could process files and package them for use on an airplane. Lastly, we wanted to be able to implement new security features to be able to help provide more integrity and security for the files that are being loaded. So this led to us having 3 main parts to our project. Firstly, like I mentioned before, we wanted to be able to take in file input and user input to create an ARINC 665 media set. This media set would be able to hold all the software that needed to be loaded onto an airplane. Secondly, we wanted to implement some form of security for these files. We chose to implement SHA-256 hashing, which takes advantage of a key to help encrypt select files of the media set to ensure their integrity. Lastly, we have a GUI portion, which demonstrates the functionality of our library and API and helps us visualize what we are creating. Overall, we used GitHub as our version control and to hold all of our code as we were developed. Our code is in C# and built upon the .NET framework. Additionally, we did all of our testing and development on Visual Studio Enterprise.
All right, so we mentioned that our library is going to create things into an ARINC 665 media set. You should be wondering what this media set actually is. So the way the aerospace industry is structured is there are many different companies, and most of them specialize in just a couple of different components that they make for airplanes. Now, this leads to a lot of compatibility issues because the different parts all have to interact both in terms of hardware and software. So ARINC, which stands for Aeronautical Radio Incorporated, is one of these software standards for packaging software that's going to be loaded onto an airplane. And it ensures that the software can be read and interacted with by all the different components on the airplane that it needs to be. Here's what one of the ARINC 665 media set looks like. The most important file here is this .lup file. That is the file that is going to be loaded directly onto the airplane. Our library generates these other 3 files about that input file. And those files contain information about the input file, things like how long it is, what part it's being loaded onto, and other information like that. So that's kind of what the ARINC 665 media set looks like. We won't go too in depth into what's actually in these files because it's literally just ones and zeros, but they do represent information about that input file.
What is an API? API or a applications programming interface. It's basically a tools that allows different software to communicate and work together. So for example, if there are like 2 different type of programs, they can like interact and then share information. API can be represented as a waiter. So like for example, a waiter at a restaurant. So for example, if let's say a waiter takes the order from the customers and they will get the food back to the customers. And the API works the same way. Works the same way. API takes the request to one of the software and they will get a response back. And then on the other hand, GUI or graphical user interface. This is basically a way for people to interact with the computers or laptops, gadgets, basically a device. So GUI generally needs to be needs to have a good design so that everyone can use it. People from the older generations or the younger generations. And some of the things that GUI examples from the GUI is like clicking buttons or dragging files, drag and drop, and yeah.
So our high-level design for the project, this is the overall picture of it. So it's the user who inputs. So typically this is a software engineer, so as will have to know what's going into the ARINC media set. So a big part of our project was to create a GUI that's completely separate from the packager itself. So it could be using automation to automate the task for developers. And on the right here, then we have the output of the media set that will show in the demo later, but that's the general breakdown of what a ARINC media set looks like. Now for the packager itself, so it's the LSAP packager. The overall design is the packager itself is a point of contact. So it's the library itself that interacts with the GUI. And we break it down into 4 parts. So it's the header file, the data file, the loads file, and the files file. And you can see these are represented in the output on the right.
So some of the major accomplishment and milestone we achieved over the quarters is we have created an API and library that is able to take files and generated a media set that is with ARINC 665 standard. We also successfully created a GUI that is able to utilize the functionality of the API and the library to create the media set. The GUI is independent so that the API and the library can function without relying on the GUI. We also added security features to do some calculations and the encryptions. Also, we did a testing on the since we have a lot of components and informations, we need to do a lot of verification in the part. We want to make sure that we get the correct informations and consistent throughout the whole system.
Okay, now for our demo, just jump over across to that. So as we said, we used Visual Studio Enterprise, and that's where we did all our development for the code. And this is our GUI, an example. So I've just pre-filled it in the information since it just takes time to enter all of it. So just a breakdown of how all of it's organized. And the 3 main parts to this would be the load type description, which is always attached to the data file, and as well as the output directory. So that's where it's going to send all the information that's created by the media set, and then the load part number. So this is unique to each company and each individual part. So the CMC just stands for the start, where it's of the company name. So like each company is going to have their own first 3 letters, and then this represents the part number itself. So once we create the media set, we get the positive result that it was created, and we'll open up in Visual Studio here. So we'll just show the part, so I selected in the documents, and then it's the CMC, and this is the breakdown. So this is, as mentioned, the files file and the loads file. And then in here then is the important files, where it's the load file itself that contains the data to update software, and then the header file. So within the header file, information is displayed as hexadecimal. You actually won't go into any of the details on the header, like the data itself, but this is just how it's represented and how we have to deal with it throughout the project.
All right, so the next steps for the project, we broke down into 2 parts, things that we need to do, and some notes for future developers. For us, we need to update our design documentation to reflect the current state of our project. Additionally, we need to provide retrospective to Astronics on current problems with the project and some things that could be updated. And then finally, we should deliver by the end of the quarter. And that would just include our documentation and a link to our GitHub repository. For future developers, there are some minor fixes that need to be made. And we could also add support for multiple media set members. So that basically means that we're generating one of each type of file right now, where there could be multiple. Additionally, the ARINC 665 standard is from the time of floppy disks and CD-ROMs. And to accommodate current communication protocols, you can wrap it up in the ARINC 827 crate. That was one of our stretch goals for this quarter that we didn't get to. Additionally, we could add integrity checking features to more files within our media set. So to sum up the value of our project is we did create a library and API that could easily integrate into existing data flows. It also creates a properly formatted media set that is extensive, and our library and API is extensible for future use, meaning it could fit into different data flows or be changed to meet changing standards. A big thank you to Doug, our sponsor, Dr. Yang, our advisor, and the rest of the Astronics team for helping us along this quarter. Do y'all have any questions?
All right, thank you.
Whenever you're ready.
Hello, everyone. We are Team CS 2306, working with Ecotope. My name is Emil Farrig.
I'm Carlos Bellio.
We would also like to extend a great thank you to our sponsor, which are Madison Johnson, Scott Spielman, and Nolan Price. And in addition to that, our faculty advisor, who was Juan Bay. And now I'm going to hand it off to Casey to talk about what Ecotope does.
So our sponsor, Ecotope, is an engineering consultant based in Seattle, Washington, and they have a focus on creating scalable and energy efficient technologies. Pictured on the right are just a couple of the local projects that they have been involved in. On the top is a central hot water system that they installed at the Denning Apartments in Seattle. And on the bottom is a heat pump water heating system that they installed at the Bayview Apartments in Seattle. And Ecotope's research team collects data from monitoring equipment placed at various sites like these all across the United States. And this data provides insights into equipment performance and resource usage, which ultimately help the company to deliver sustainable, reliable, and cost-effective engineering solutions. So the raw data that Ecotope collects has to be directed through a data processing pipeline to be cleaned, transformed, summarized, and stored for later analysis. The problem is their current data processing system is outdated and it's challenging for them to maintain and update. So to address this, our team set out 3 main objectives for our project. First, we wanted to develop an updated data processing system that is flexible, easy to use, and easy to extend to new projects. Secondly, we wanted to demonstrate the use of this system for some of Ecotope's active projects while working with their real sensor data. Lastly, we wanted to provide thorough documentation on how to use, modify, and extend this system. And by meeting these 3 objectives, we will help Ecotope have a new and improved data processing system that they can use to maintain their ongoing projects and extend to their future projects. And now Roger is going to talk about our solution.
All right, thank you, Casey. So to meet our objectives, our solution was to create a Python package that will gather and process data collected at Ecotope sites. So our package has been tested and implemented at their Bayview and Lawrence Berkeley National Laboratory sites. And we've designed our pipeline to act as a blueprint that will assist Ecotope's future pipelines, the creation of Ecotope's future pipelines when they plan to develop them. Furthermore, we've ensured that our code will have sufficient documentation that will help explain to them what exactly our pipeline package functions. All right, so here we have a simplified view of how our package will run. Starting at the top, the extract, our package will first pull raw sensor data and weather data from the sites and load them up into data frames. From there, the extracted data frames will go to transform, where a majority of the work is done. But first, the data needs to be processed and cleaned. For the most part, this will just include removing missing values, outliers, and so forth until the data is fully cleaned and ready ready for us to perform calculations on. Now, for those calculations, they vary from site to site, but some common ones between all sites would be calculating the coefficient of performance, or the COP values of the sites, along with just keeping track of the overall power and energy levels of those sites. Then once all the calculations are done and we've added them into the data frames, they'll be it'll all be aggregated, and then they'll be separated into 3 separate tables: a minute-by-minute table, an hourly table, and then a daily table. Then after this, we move on to load, where we'll establish a connection to Ecotope's MySQL database. And after setting configurations of all the tables and everything's fully processed, we'll then upload it to the database. Okay. And now for our solution for documentation, we've mentioned the importance of maintainability and reusability. So in our README, we made sure to include comprehensive information on the structure and architecture of our pipeline, how to add new functionalities to existing pipelines, instructions on the creation of brand new pipelines, and also proper unit testing procedures. And then to make new documentation, we've used Sphinx to generate a documentation based on like written comments in the code. And then we've also included instructions on how to use Sphinx to generate new documentation for future pipelines. And later on in the presentation, we'll show examples on what this documentation looks like and a run through on the pipeline itself. Now I'll pass it off to Julian to go over our work structure.
Thanks, Roger. So for our work structure, we decided to use Agile Scrum methodology in order to meet the goals of the project. The epics our team decided on were our main overarching deliverables for the project, being our supporting Python package, our reconstruction of the Bayview pipeline, and the reconstruction of the LBNL pipeline. The Agile themes were the essential components of each of those epics, being the extract, transform, and load capabilities for each. And our user stories were specific function implementations for those themes. So for example, task might have been COP calculations for Bayview within the Python package for transform. The whole process took us about 21 week-long sprints over the 2 school quarters that we used Agile. The team milestones that we had outlined and completed included milestone 1, which was our generic Python package. This included the outlining of our basic extract, transform, and load structure, as well as outlining our basic unit testing structure. Milestone 2 was the implementation of specific functions for that Bayview site, as well as associated testing. Milestone 3 was the demonstration of our package in the reconstruction of the Bayview pipeline using sample Bayview data and a test MySQL database that would simulate how Ecotope was going to use the package on their own. Milestone 4 was the implementation of specific functions for the LBNL sites, as well as related unit testing. And then milestone 5 was again another demonstration of our Python package and the reconstruction of pipelines for LBNL. LBNL is a little bit different than Bayview, as there are multiple sites that need to use the same code. So we demonstrated for several to show the versatility of our code. And our final milestone was the completion of all of our unit testing and documentation, including detailed comments for all of our functions, as well as a README on the package GitHub detailing the package's features and how to best use them. I'm going to pass it off to Carlos to talk more about documentation.
As we mentioned earlier, documentation is very important for this project. And so we documented it in 2 main ways. So first is the way on the left, which you'll see is the Sphinx automatically generated documentation. So the way Sphinx works is it goes through our code and our comments and generates a website that contains all of the documentation regarding how our functions and how our data pipeline works. So the way this works is they can run this Sphinx package whenever they want, and it creates a new website each time. So every time they update the package, they'll have a fresh website with all of the latest stuff already on the website. On the right, you'll see the GitHub readme.md. So the GitHub readme contains more on how the framework works as a whole. So the framework of how the files are structured, how to add functions, how to modify functions, and also how to test functions are all on the GitHub's readme.md. You can see how it also gives you instructions on how to install the package and also how to document the package further. Next, I'm going to proceed with our demo. So I'm going to demonstrate the data pipeline package working for one of the sites, which is the Bayview data pipeline. So right here, you can see an IDE, which is a code editor, and we're going to focus on the 4 main files that let this pipeline run. Right there, you can see the 4 main files: extract, transform, load, and pipeline.py. So first, we're going to dive into extract.py, which is the first file in the step. So here you can see that we're importing the package that we created and the functions that we're going to use. We use the function sequentially and import the data, the raw data, and then eventually pass it off to transform. Here you can see the different modifications we're doing on the data before finally passing it off to the load part, where we create a connection to the database and upload all the data onto the database for the engineers to eventually query. The last step is the pipeline.py, where we import the extract, transform, and load files that you saw earlier sequentially, and it will tell us when all of these parts are done. Finally, it's a Docker file. So Docker helps us deploy this pipeline wherever we want. So it's just, it should work consistently everywhere. To deploy the Docker file, there are instructions in the included README file on how to deploy it. So right now you'll see we're going to copy the build script to build the Docker container. So we're copying that script right now and pasting it into the terminal. So right now you can see it's completely built the Docker container, and now we're going to run the container. Running the container runs the data pipeline, and you'll see at the bottom that it will slowly download all the files and then do the connection to the database and upload the file. Now we're going to switch to the MySQL view, and here we're going to see that there are new tables generated based on the data pipeline, and then we're going to query the database to show that the pipeline has fully processed the data. And now you can see the fully processed data on the MySQL server, ready for any Ecotope engineer to query. Now I'm going to pass it off to Emil to talk about the conclusion to our project.
Okay, so this data pipeline essentially makes it so that Ecotope can interpret raw sensor data. And in addition to that, also to prove the efficacy of green energy building components. So as an example of one of our sites, we were working with Bayview. We were interpreting the efficacy of a hot water heat pump. And essentially what that does is it uses air, surrounding air, and a compressor to create thermal energy, which is then used to keep water in an insulated tank warm. And the COP value that we calculated for this was essentially a ratio of the amount of thermal energy that was created over the amount of energy that was sent to the compressor to create that thermal energy. So essentially, it's just an efficiency value, which tells you how effective the building component is. And with that information, Ecotope is able to recommend those building components that have proved effective in their research to partner firms like Puget Sound Energy, which implement them at scale. So one of the lessons that we learned, the most important one actually, was that teamwork makes the dream work, especially communication. So one thing that we realized is that when we really focused on this between ourselves and our sponsor and faculty advisor, our sprint velocity increased greatly, which is essentially the amount of work that we got done per sprint. And in addition to that, our meetings were also much more effective because our sponsor and our advisors knew what we wanted to talk about. And so all of our questions and concerns, we were able to get to those thoroughly in each of our meetings. And in addition to that, it was also to essentially create an environment where everyone felt comfortable sharing their opinions. And that just allowed us to come up with creative solutions to the many problems that we faced during this project. So looking forward, the Bayview pipeline is currently in working order, as you just saw demoed. However, the LBNL pipeline still needs some work. So there are differences in the data from site to site, which still need to be taken into account. And then in addition to this, Ecotope has also verbalized their willingness to create a data dashboard so that they can more easily present their findings to their partner firms. Thank you for listening to our presentation. And are there any questions? Yep.
Yeah, so one of the ways we automated our testing for this project is we created unit tests for each of the functions that we made. So we subdivided the project into different modules, and each modules have 2 or 3 unit tests per function. Afterwards, we also, so they had the pipeline running previously on this archaic code. And so what we did was we created a script that compares our output with their output. And we compared this for multiple days over multiple sites and multiple data sets, and check what is our margin of error from the stuff that they've collected prior. And we got almost 0 margin of error for most of the testing. And I think Emil can add to that too.
Yeah, so essentially it was just a function that like took a column from 2 data frames and then just calculated the average error for those. And we were only really doing that for columns that we calculated. So for example, the COP column, which is the one that they are most interested in. And yeah, for that one, we got that's negligible error for that. So, and yeah, in addition to that, we had what Carlos was talking about, a function, a unit test for each one of our modules. And then we also had a kind of like the pipeline.py where we would test all of the functions like working in unison together so that we knew that not only did they work in and of themselves, but they also worked in tandem with the other functions as well. So, yeah.
So, I think this is the action database.
Yeah, that's a good question. So we did use the database in our unit testing. So what we would do is we would essentially run all the processing. We would put it into the database. And then if we ever needed to know what was in the database, we would just query that like in a unit test and then compare that data against what we got. So
Yeah, and on top of that, we also added a lot of fail safes and error checking in our code. So if, for example, a connection fails, the script fails successfully. It's a great way to put it, but it doesn't cause any problems if it fails. So we made sure to account for that in all of our code, considering that there's a lot of moving parts. Like, what if the SQL server is down for the minute that we're running it? So all of that is, we tried to account for it. Of course, we can't account for everything, but as much as possible, we tested the most common errors and created error checking for all of that.
I just want to know your experience with these 1-week sprints. If you recommend future teams using 1 sprint.
I think it was probably not the best idea to have such short sprints. Probably in the future, I think 2-week would allow us to have be more productive with the progress we make in each sprint.
Yeah, and a lot of our 1-week sprints, our tasks wouldn't finish by the end of the week. So we ended up carrying those tasks to the second week. So it ended up becoming more like 2-week sprints. But the advantage of doing the 1-week sprints for us was that we got to regroup and course correct right away. So if we realized, oh, we accidentally assigned person A double the amount of tasks that another person had, we were easily able to reallocate those tasks. We were able to take on stuff from each other, and that was able to help our velocity. Thank you.
So, hello, all right, so let's try that again. So we are the Visiting Angels. We are team 2321. And to introduce our team a little bit, my name is Luke Schroeder.
I'm Katie Pryle.
I'm Sebastian Cook. I'm Daniel.
And our faculty advisor was Professor Eric Larson. And for our sponsor, the person that we had the most contact with was Tina Valdez. She's the owner of the Visiting Angels of this particular chapter of the Visiting Angels. And then the person that we were designing this app for is the Caregiver Experience Manager, Danielle Winston. So a little bit of context about our sponsor. They are a home healthcare company. So they help people who are elderly, sick, or just in need of a little bit of extra assistance. So they can help with cooking, cleaning, and just taking care of people like if they have a surgery or something. And so they came to us in September with a problem. Their problem was their scheduling system. They are their previous scheduling software was a little bit old and out of date, and it made it really hard to use. So their scheduler kind of picked up the slack and ended up basically doing the entire schedule in their head. So our goal was to make her job a little bit easier, and so she can take time off in case if there's an issue. So our solution for this was to create a web application. So our web application interacts with their previous software, Access Care. And this allows us to improve the schedule. So our main goals were to improve visibility and to filter through caregivers more effectively. So some of the technical goals that we had was to use a CSV file upload to populate our own database. This allows us to be in total control of the user interface and make it as easy to use. So, and then our second key feature was to work on a full picture visual schedule and filtering. So this allows the scheduler to access the data and make it very easy to use.
Yeah, so the theme of our project was easy scheduling because our goal is to make scheduling shift easier for both the caregivers and the scheduler who are working for Visiting Angels. And we kind of had three main epics. First, we wanted the scheduler to have a clear full picture view of the availability schedule so that it would be easier to match the right caregiver to the needs of the shift. And we also wanted the scheduler to be able to find specific caregiver with certain attributes using a filtering method. And we also want them to be able to upload caregiver and schedule CSV from Access Care onto our system. And we'll kind of explain more of what that is later in the slides. So yeah, so we have two main user stories, kind of similar to the epics. Basically, we want the scheduler to have a full picture view of the availability schedule and just the work schedule. And also we want them to be able to find the right caregiver with certain attributes so that they can assign the client with the perfect caregiver who fits their needs.
So to cover the logical architecture that we went forward with designing this application, in terms of the backend, we focused on a model view controller pattern, which allows us to separate the dependencies depending on the project's needs. So to give just a very simple rundown, essentially, is that we have our main controller. This is where inputs are both received and outputs given back to the user, or in our case, the front end of our application. And with the information that's provided as an input is passed to our backend business logic, where we will process the CSVs, and this will be passed towards our data access layer and into our database for storing. And then that allows us to then search and filter through the information we have in our database.
Yeah, so this is our physical view. Basically, the scheduler will be using our web app, which will be built using React. And from the React or our web app, we'll be calling different APIs to retrieve or update our database that has the caregiver information and the schedule, which will be hosted in the Visiting Angels server. So for our sprints, we did a 2-week long sprint and total of 7 sprints in total for our development cycle. And we used Kanban style story loading as we took on new tasks. Yeah.
So to go over the general schedule of how we operate over the full 9 months is we broke down our project into a couple main sections. So we have our initiation and research and design, which is where we initially interacted with the sponsor and figured out the needs of the project and how to move forward with them. We then spent the majority of our time in implementation and creating a minimum viable product that can be used by the company. And over the last 3 months, we've spent time polishing, unit testing, and ultimately deploying it onto the servers at Visiting Angels.
Yeah, so these are some of the tools and technologies that we use for our project. So for our backend, we use .NET and C# because it supported object-oriented programming language. And we use Entity Framework Core because it gave us a way of just using the database. And for testing, we use mock and unit. Mock specifically because we have some dependencies in our system. And for frontend, we use React. And for database, we use MySQL Workbench. And for development, we use Visual Studio or VS Code for our IDE or code editor, and GitHub and Postman for just testing our APIs.
So I'll be showing the main full throughput of a demo of our backend. So to start off with, this is the program that Visiting Angels was using previously is Access Care. And essentially what we're starting first with is we're downloading the information of all the caregivers. So this is just saving a CSV file, which stands for a comma separated value file. It's essentially just an Excel sheet with commas in every row. And we're also going to be doing the same on our downloading the schedule of the caregivers. And we're working on a 2-week bi-weekly period of pulling the schedule of caregivers for every 2-week block. And we're also using a CSV in this instance. So just to show what it looks like, just sort of the scope of the data process we're doing, just for the caregivers, I believe there was between 30 to 40 fields that we were parsing and loading the information from. And we're essentially creating a caregiver to store into our database and taking all of these fields and putting it into the object so it could be filterable in the future. This is also showing the schedule and a major portion of development that went into this portion of the project was an issue that we came up with, or that we came across, was that in this comma separated value file, the Access Care was also using commas to separate individual times, which was causing an issue in our backend. And in order to resolve that issue, we ended up having to use a different formatting style for this Excel file to adjust for this. So here on this page, we had to change using the system separators, which defaulted over to the EU styling, which allowed the file to use a semicolon to separate all the values rather than commas, which then allowed us to do a full throughput and upload the information to our database. So here we're using Postman, and the only thing to really focus on this page is the happy green box with the 200 OK, which means that we're uploading the files into our APIs and we're getting a positive response with no errors. And this is also just showing the integration with our front end. We have here our load data page, and the use of the word class here is just in reference to how Access Care refers to it. It's a common class file, but in a sense, it's caregivers. And here we see the happy 200 OK, and this is our database. And this is us just showing that we've taken the information from these comma separated value files and we've put it into our database. And the same can be seen with our schedule here. And one major point that we came across was in terms of, or a accessibility thing, which was nice to have, was another feature we added was having the ability to have the exact dates shown within the tables, so that it's not just day 1 through day 2, it's showing the exact month and date of the exact schedule. And I'll hand it off to Katie for the front end demo.
Hello, so I'm going to be going through a demo of our user interface. So to start up using our application, we need to download all the data that we get from Access Care. And Sebastian just showed the backend version of that. But right here, I'll show you how you do it as a user. So you come to our homepage, click on load data, you choose a file, you import the file, and you do that for each of them. And then the backend does its work, it does its magic, and you have your data loaded. And now you can do what our application is actually used for. It is filtering caregivers and their schedules. So here we have different filters that you can select from, and you can also search by the caregiver's name as a bonus. So let's say we want a male caregiver located in Seattle that's okay with pets. And then you can scroll down and it filters and it shows the schedules of each of these caregivers that fit these criteria. I'll also show that the name search works, but the names are blurred out for security reasons. And so that is our application. Okay, so wrapping up our project, we have deployed the application on Visiting Angel servers, and we create a documentation packet. This will help Visiting Angels work with our product, and it will also help future projects to then build on top of our product, because there's a lot for this app to expand to with future projects. And so wrapping up our major lessons learned, we learned a lot of business skills. We were the first team to have this project. And so we went in and we were able to talk to Visiting Angels and Tina and Danielle and really determine how to make their vision come alive and what we can do as engineers throughout this project for this project. And so it was a big learning opportunity to actually experience that and go through and determine what we can do as engineers. We also learned how to design software from scratch, what tools to use, etc. And then on top of that, we had technical skills. We learned database design, API design, and front-end design. And so the big takeaway from how our project benefited Visiting Angels in our community is better scheduling equals better care. By creating a scheduling tool, we provided Visiting Angels with a better, easier way to schedule so they can provide better care to their clients and expand their company. And so to wrap up, I want to thank our Visiting Angels sponsors, Tina and Danielle, and our advisor, Professor Eric Larson, for this opportunity. Do we have any questions? Well, thank you for your time.
Hello, we're our ballot box bunch. My name is William Alikar. To your right is John Bjorgi. Right here is Rafay Khan, and right here is Quinn Goldstein.
So our advisor was Brian Doherty, and then our sponsor was Tom Thomas. And just going in to give you a little bit of an introduction about Votegrity. So Votegrity is a software company that supports elections for private groups such as homeowner associations and unions. And the product of this company will allow any organization to hold a fair and secure election via electronically and on paper. Votegrity software gives election administrators a simple solution to running their own elections with easy customizable ballots and a straightforward voting process. Votegrity expects with this solution, it empowers voters to take more control of the election due to its convenience.
So the problem Votegrity brought to our capstone team was they wanted to find ways to increase voter turnout. As you know, an election is only really considered valid if you have a certain amount of voters that participate in it. So to do this, we were trying to increase the ease of use for voters to make it easier to vote than before. And we wanted to amplify their experience in general to make voting just more enjoyable, easier, and streamline it. We also wanted to assist them with some DevOps work to help their developers build, push, test code more easily than before. So to do this, we came up with a few things. So step one was we wanted to implement a one-click login for users to access their ballot. So before you would get a link to your ballot and you'd have to enter your username and password. We customize each person's URL so it automatically logs them into their ballot, making it easier than ever to vote. We also needed to maintain security standards, so we had to encode user data and make sure that these links couldn't just be brute forced easily to give anyone access to elections they weren't supposed to. We also added SMS notifications to increase voter turnout. We can now send text messages to users detailing when an election starts, when it ends, and you can even click a link to vote from your phone. We also wanted to develop a build pipeline for developers to push code and run tests more easily.
So just going off what John was saying a little bit, so creating a personalized ballot link was one of our main deliverables, and it offers several benefits for the individuals and organization involved in the voting process. So personalized ballot links can enhance accessibility or access by providing voters with unique URL that lead them directly to the customized ballot, which will also enhance the security. Along with that, this eliminates the need for searching or navigating through a complex voting process, and it's easier and more convenient for the individuals to participate in the voting process. Along with this, we're hoping that it will bring out voter engagement and trust. Personalized ballot links can help build trust and engagement with the voters by receiving the unique URL. Individuals may feel more connected to the voting process, and since they're getting a customized ballot. Along with that, with text notifications, it will bring out convenience and timely reminders for the users. So everyone nowadays has their mobile devices. So instead of being on a laptop and ensuring that your vote goes through that way, you'll get timely reminders knowing that, hey, your ballot's coming up, so you vote, and so you get a higher voter turnout. And the user's vote is actually making an impact for what they want it to be. Along with that, we created a CI/CD pipeline, which means continuous integration and continuous deployment. So a lot of developers can work at the same time, push code, and see through unit test if the code is successful or not, which we'll show you a demo of later on.
So here we have an architecture diagram for you guys. So we're showing the voter process and how they interact with our system here. So as you see, the voter will receive a link to a ballot, and then under the old way, they would have to enter their login name and password in order to access their ballot and actually vote. Under our new system, this is bypassed and they're automatically logged in via the token attached to their customized URL. Then they're able to vote on their ballot and submit their vote as before, but obviously log in more easily. And then after that, we have them submit their phone number and confirm it so that in future elections, or even for the end of this one, they can receive text messages with information about it. This hopefully increases the voter turnout and the experience of the voters.
All right, yeah, so next up, we'll talk about some of the tools and technologies that we worked with. So some of the existing tools that we got from our sponsor included a GitHub code base. The the back end uses Python and the Django framework, while the front end uses JavaScript and React. The database uses PostgreSQL as its query language, and we worked in Visual Studio Code as our IDE of choice. Some of the new technologies that we implemented, though, included the PyJWT library. That's JSON web tokens in Python, which we use to tokenize links. We also use the Twilio API to send text messages to voters, and the pipeline was hosted with Microsoft Azure. Next up, we'll talk about the build and how our team kind of carried itself throughout this project. So we use user stories and epics to track our progress throughout this project. User stories include perceptions about voters and statements from those. So this could be something like a user saying, oh, I want to be able to vote on my phone. And epics were big picture goals, just such as like sending text to voters. For our sprint operations, we use the Agile methodology, working in 2-week sprints throughout the winter and spring quarters and having weekly stand-ups with the team, getting our advisor and sponsor involved at least once a week. When it came to resolving blockers, we worked with a company engineer. So here I want to give a shout out to Jesse, worked for Votegrity. I think he's on the Zoom call right now, but a major props to him for just helping us out, and weekly coding sessions with our sponsor to get those blockers finished.
Yeah, and I'll be explaining our major accomplishments. So we got tokenization to be completed. This basically means that a tokenized link can automatically log in a user. We also got SMS verifications to work. So when an election has ended or when an election has started, the user will get their SMS notification. And this notification will also have a tokenized link just to increase the convenience of using Votegrity. We also developed automated testing so that when new developers want to push code to the existing code base, they'll just run the automated tests to make sure that it doesn't break the existing build.
So we've mentioned this a couple times, but one of the core pieces of this project was tokenizing these links that we're sending to users. So obviously we need to make each link unique. And we figured the best way to do this was to actually take the user data and encode it in a secure way that we could attach to the URL so that when it's received by our server, it can be decoded and we know the identity of the user trying to access it. This is obviously better than like just including the username and password in the URL for security purposes, because being publicly passed, any browser data leak would lead to your login password being leaked. We used JSON web tokens to encode the data using the PyJWT library that we mentioned earlier. And we generated a unique key for each election so that in the event of a data breach, only the keys that are actually leaked would lead to invalid elections, hopefully saving Votegrity some hassle and needing to rerun multiple elections. But using these tokens, we were able to customize URLs for each user and streamline the voting process.
So just going a little bit more in depth about SMS. So in order to send an SMS to a user, they need to register their phone number to Votegrity. So we developed a web page where a user can put in their phone number, they click submit, then their phone number gets the confirmation text. This confirmation text has a tokenized link. So when they click the link, it's going to add their phone to Votegrity. And this is all done using Twilio API. So right now I'm going to be showing you a demo of what we made so far with SMS and tokenization. So let me just switch my screen here. So when an election starts, usually a voter gets an email. This email contains 2 tokenized links. So I'm going to be clicking this first tokenized link. This is to actually vote on Votegrity. So I have this ballot. It automatically logged me in. So I'm going to start it. It says, do you like the code? I'm going to say yes. And I'm going to submit this ballot. So now that I've successfully casted my vote, I want to register my phone number for SMS notifications. So now I'm going to go click the SMS verify page, and I'm going to put in my phone number right here. So once I click the submit button, I'm going to get a confirmation text on my phone. So Votegrity sends me this, confirm your phone number by using this link. So I'm going to click this. And it says, thank you for confirming your phone number. So now Votegrity recognizes or uses my phone number. So when an election ends, the admin would release the results, right? So I'm just going to end this election and I'm going to look back into my messages and it says results are out. So I'm going to click this link too. And I can easily view the election tally. So it shows that one person said, yes, they like the code. So that is kind of the end of the demo. It basically just shows you how convenient it is to use Votegrity with tokenization and SMS. It just makes a seamless user experience on your phone. So regarding testing, we did SMS and tokenization tests. This test basically worked with the back-end functionality of these 2 things. We also did performance testing. This is important because we want to make sure that our code doesn't slow down the existing website. So we made sure that didn't happen, and seems like our functionality is great. We also did successful pipeline testing. Raf will talk to you about it, but we have this pipeline that whenever we push code to our existing code base, it's going to run these tests and make sure it doesn't break anything.
Thanks for the introduction, Will. So a little bit about the pipeline. So you can transfer code from like VS Code to the pipeline and see if the test works successfully. Along with that, we're using a self-hosted agent. So there's a Microsoft hosted agent and a self-hosted agent. And the self-hosted agent is basically just taking place on my computer. So whenever I open up my terminal and get the CD runner going, which basically activates the pipeline, anyone can push code as long as you're in the GitHub file. You can pull out the repository, push code, and make sure that the pipeline runs successfully. And we'll have a demo of that. Along with that, we entered pip installations for JWT and Twilio, which is code we were working with to make sure the pipeline was running successfully. And it's not running on Votegrity servers right now, but Votegrity is going to be using the self-hosted agent on their own VM. So it'll be running 24/7. So they won't have the issues that we had with our self-hosted agent. And we're going to show you a demo of it right now. So right now, as you can see with the terminal screen, I basically activated the pipeline, and now Will's going to push some code to the pipeline, and it's going to show that it's going to be running within Azure DevOps. So now you can see the pipeline is running, and you can see it's been done by Will. And so when we go and see what the job is doing, it's first of all going to be just queuing it, getting it all processed through. And then it's going to have some installations that are installed for like the pip installments, and it's just going to make sure all the objects are successfully running through. So when we look at it, it's just counting the objects within the file. And then right here for the CMD line is adding the pip installations to our code to make sure that the unit tests are running successfully. And whenever there is an error within our pipeline, it's going to show an X to show, hey, there are some errors, even if tests are passing. So as we can see right here, we have one test that passed and then two failed. And so whenever there is an error where a test does fail, the cool thing is it shows you which file in VS Code it would be failing on and what line. So we know it's test example .py and line 10 where the error is occurring. So now we know where to go fix our error and go run the test again to make sure it's running successfully.
All right, so now we'll talk about some of the lessons we learned from this project. So as our advisor will probably attest, it's really important to stick to your sprint board for gauging progress within those 2-week sprints we talked about. Our team found a lot of value in pair programming. I think some of our best work came when we all just sat down and really got away grinding some code. Our sponsor actually gave us props for asking questions throughout this project. It's really important to ask the right questions too, especially acknowledging that you don't know something. Other teams will probably talk about this, but communication is key. It's really important for visibility and having responsibility among all your team members. And finally, we did a good job, I think, at keeping our documents up to date. We had someone from the industry come in and review our project, and he gave us some props for not having stale documentation. And I think that's something that we did pretty well throughout the end of this project. So yeah, we'll kind of conclude it here. So some next steps for our work after we hand it off to the company. We considered other security measures. If there's ever a data leak, whether internally or with a third-party group like Twilio, there should be some sort of contingency plan. And we talked to our sponsor about maybe setting that up in the future. We also talked about other methods of voting. One thing our sponsor talked about as like a stretch goal was voice voting, where users can just call an automated machine and just talk into it and vote like that. We'll also talk about the value to customers that we're bringing. So like we said, we expanded voter coverage by adding SMS notifications and streamlining the voting process, making it easier for voters to access their ballots and let their voices be heard. And we're also really proud to say that our work will be moving into production after we turn this over to the company. And we're really excited to see those features get implemented. And I want to close this with some thank yous. So first of all, thank you to our sponsor, Tom Thomas. He's not here right now, but it was an absolute pleasure to work with him. Just really did a great job at supporting the team's needs. Thank you again to Jesse McQuillan, Votegrity engineer. He was always there to help us fix the code. We broke the server, I don't know how many times. And you know, he was always there, even if it was like 10 p.m. He was like, yeah, I got you guys. We want to say thank you to our advisor, Brian Doherty over there, for just making sure that our heads were on straight the whole project. And we kept progress going. And then I'll finally thank you to Jason Wong. I don't think he's in the room, but for just putting the whole capstone program together. And thank you all for coming to our presentation. We'll open up to questions. We'll go front row over here.
So we're distributing the same way that they'd been distributing the links to the ballot in the past. So it's basically just over their email server. So that is a potential risk in that if it was compromised somehow, obviously they could be sending the login URLs to people that they're not supposed to have. So we're kind of just trusting in the security that Votegrity already had in place to make sure that you know, election admins are only sending ballot emails to the right people. Yeah.
I think the first lesson here is stick to the springboard. Can you elaborate on that?
Yeah, so we use the Springboard, I think, as a point of reference throughout all of our, you know, weekly stand-ups, meetings with our advisor and our sponsor, making sure that our task board, I guess is also another word for it, was clean. We were keeping progress of everything we were working on correctly. It was also a good tracker for like our minimum viable product, MVP, if you're familiar with that term. Yeah, just to make sure that we were getting everything done and laying out the proper rubrics, if you want to call that, for all of our work.
Yeah, so Votegrity already has pretty good features for scaling in the way that the URLs are generated. They're already queued to run sequentially. So it's not too much of an individual load on the server to generate all these tokens at a time. And also the login process, it uses a very similar login process to what Votegrity was already using. So it should scale pretty much the same as just generating the emails that they were already sending to voters with their ballots and logging in. Yeah. So right now it's only in private sector. Some of the biggest issues moving to public, like with the government, as you mentioned, would be a lot of security upgrades would potentially have to be made just because it's being run over the internet right now, which is potentially more dangerous than some of the closed system elections that we use already. Another potential issue would be just the mainly just security upgrades, just making sure that it's secure enough and making sure that the encryption that they use for encrypting ballots and everything is up to the standards of the government and making sure that those elections can be considered legitimate. Okay, well, if there are no more questions, thank you guys for coming.
Oh, wait. Okay, hi, everybody. We are the Ellebit team, and Ellebit means to elevate every bit of your experience. So our senior project team consists of Richard, who is this quarter's team coordinator, Clayton, who is this quarter's Scrum Master, me, Mari, who is this quarter's architect, and Casey, who is this quarter's business analyst. Our sponsors are Anna Del Toro and Kathleen Powell, and our advisor is Dr. KH. So what is Ellebit? Well, Ellebit is an all-in-one booking platform to easily manage private dining events for reservations and catering in real time. Essentially, private dining is a restaurant dining space which is completely sectioned off from the main dining area by way of door. The problem our sponsors discovered is that planning and managing private dining events is time-consuming for both the patrons planning them and the restaurant venues. This is the current system for booking a private dining event, which is time-consuming and lengthy. In order to book a private dining event, patrons must initiate the booking through forms, phone calls, or emails. This process can take days to finalize, and additional days or weeks for menu selection, contract agreement, payment, which are all currently manual processes. But with Ellebit, these manual processes will be automated. This is our revised version of the system, going from a 35-step plan to a 6-step plan. Here, patrons can make their requests online, which can easily be accepted or declined by restaurant venues. Ellebit helps patrons easily manage their reservations in real time, while also allowing restaurant venues to focus on the guest experience and manage booking details. And now I will pass it off to Clayton, who will discuss our project goal.
All right, hello, everybody. Our goal for this project was to create an easy-to-use reservation management system where restaurants can sign up, create and receive reservations all in one place. For the project, we needed to deliver a web application hosted on AWS, along with handoff materials to support the continuing build on Ellebit. And now we're going to talk about how we implemented the project itself. So for the application's architecture, we have the application running in a Windows web server on AWS, and that's also connected to an AWS relational database. Some of the technologies we used was for the design, we used Figma to mock up the pages of the website. Development, we used Visual Studio to code in and GitHub to store our code. For the backend, we went with Microsoft's ASP.NET together with Blazor Server for the front end. For the database management system, we went with SQL Server. This is in conjunction with the object relational mapper that we chose that's also integrated into ASP.NET called Entity Framework. If anyone's unfamiliar with an ORM, all it does is helps convert data from the database into useful objects for the application. And for the cloud deployment, we hosted it on AWS. Now I'll pass it off to Richard to talk about the project structure.
So, thank you, Clayton. So yeah, I'll be talking about epics, themes, and user stories that we focused on for this project. We initially wanted to center them around the patron and restaurants and their interactions. For example, we wanted patrons to be able to have access to a comprehensive initial request form that they would send off to restaurants. On that same page, we would wanted them to see snapshots of rooms available for that venue and information such as like capacity and amenities available for that room so they can make more informed decisions for their party needs. On the other side, we wanted restaurants to be able to control certain steps of that reservation process, such as that initial request form, menu selection, and then the contracts that would go with that reservation. On top of that, we wanted to give them more ability to update their reservations up until the finalization step of that process. As for our sprint schedule, we mainly focused on using Agile at first and its methodologies. But a few sprints in to our first quarter, we realized that didn't work very well for us. We kind of shifted to more of a hybrid Agile / Kanban type of software development. And for those who don't know Kanban, it's kind of like a progressive task board with certain columns of like to do, in review, and then done. The reasons we did this was to improve our productivity on working on the project. The Kanban board really helped us visualize what tasks are being done and by whom, and it allowed us to identify any like bottlenecks we were having on certain features we were developing. And the second reason was for accountability. The Kanban made it very easy to make it transparent on who was working on what task, and allowed us to be just as transparent to the sponsor what tasks were being done for that certain week. Overall, it helped us in providing more meaningful updates to when we had sponsor meetings, so that we can get better feedback about the work we were doing. And then I'll pass it off to Clay for our blockers.
All right, so some of the blockers that the team encountered was the lengthy design process of the website before we started actually coding the website. The team took about the majority of winter quarter just on design itself, so this slowed down development. Another blocker we had was the menu upload. We'll talk about this later in the demo, but the feature originally planned for having the restaurant be able to upload their PDF version of their menu, and it being able to scan it for menu items, which would add it to their menus on Ellebit. We realized it was pretty hard to do this because PDFs are unstructured. So instead, the team opted for a CSV file instead, which is similar to an Excel file for the upload process. And then also, additionally, another blocker that the team encountered was the limited time to develop a marketplace. So if users wanted to go onto the website and browse for venues that they would want to make a reservation at, we didn't get time to implement that, but instead we implemented a unique link where restaurants can send the link to the patrons, and that's where they make their reservation requests with. And we'll also demo that.
All right, thank you. But I'll be going over some of the milestones that we completed during the duration of this project. So to combat some like the web design issues, we went and used Figma, which is a great web design tool that lets you to template and understand your webflow better. We use the menu upload and menu selection to allow us to parse CSV files that the restaurants will supply to us, and then that will populate their menu items in our backend. The unique reservation link that allow patrons to make reservations all in one single link. And this all helped build us up to our web application that allows patrons to make reservations through that unique link, and restaurants to edit those reservations through their dash. Now we will move on to the demo portion. Oh, sorry. These are some snapshots from our Figma board. As you can see, there's a restaurant and then some of the rooms available, an example of test form, and the menu that would go to that venue that would be populated from our menu upload.
All right, thank you, Richard. So we're gonna get into a little bit of the demo because I'm sure you guys want to see it. This is the restaurant venue interface where you can see the dashboard of all of the restaurants that you own. If we click on that first venue, it should pop up a different dashboard, which shows you all of your customization options. This is the information that will be displayed to the restaurant patrons when they try to make a reservation request. You'll see that we have two buttons for logo and thumbnail. The logo will be white gloved into the reservation process, which we'll see in a little bit. And the thumbnail is for reservations as well. If you click on settings, it's very mistake friendly or adjustment friendly. If you want to change any of your information about your restaurant venue, you can do so here. For now, let's just go back, and I'm going to pass it off to Clay, who's going to talk about the menu selection and menu upload process.
All right, so now we're going to talk about everything about the menu. If we go to this link right here, you can see all the menus that you have at your location here, or you can create a new one. But for right now, for this demo, we're gonna go to a menu that we created, but there's no menu items in it. Or there might be menu items in it, but there's two ways to add menu items to this menu. We're gonna go through the first one for the menu file upload process. And you can download a template for the a la carte menu items or the fixed price menu. So the difference between the two is that for a la carte, the prices for the menu items vary in the menu itself, while for the fixed items, they're all the same price for that menu. But since we already have a filled out template, we're going to use that to upload instead. And once we click this button here, it'll scan, the server will scan the file and scan for menu items and upload it to the menu. Yeah, it's duplicating right now, but that's because we already had, we uploaded our menus already, or menu items. And then if you make a mistake or you want to add additional menu items, you could also go to this page here, edit your menu items or add. And then if you want to edit any menu specific settings, you could go to this button and do so there. And that concludes everything with the menu. I'll pass it off to Casey to finish the rest of the demo with the reservation process.
All right, thank you, Clay. So as we talked about before, a really important part of this is the reservation itself. To initialize a reservation, you just have to click this reservation request button. And as you can see, there's a list of all the reservations that you have existing right now at different stages. We talked about the 6 steps that are in our solution, and it's 3 steps each from each side. So 3 steps for the restaurant and 3 steps for the restaurant patron. For now, we're going to create a reservation link, which will pop up a little tab that shows your unique reservation link. You can also email it if you want to initialize the request. So for the rest of the demo, we're going to have the left side represent the restaurant owner and the right side represent the restaurant patron during this reservation process. So Richard's going to go in and use the unique link. As you can see, the logo is white gloved in there. So you can type out some initial information about your party or your reservation request so that the restaurant is aware of your initial request. Set up some information that will give them some, they'll have to approve it after they receive the request. So he's going to click the room, and as you can see, the rooms will pop up so that you can select from the list of rooms. So after you send that reservation request, it'll send it over to the restaurant owner and it'll pop up in the venue. So as you can see, my name popped up and Richard is going to review the request. And if I seem trustworthy and he likes my reservation request, he can accept it. That will update the link for the restaurant patron one more time for the second step, which is the menu selection. So we'll click on that demo menu that we uploaded and you'll see that the menu items that we uploaded with Clay are uploaded here. And if we select a few of these, it will get added to our subtotal so that the restaurant patron can see the information. They can also add notes if they want to accommodate different requests, allergies, whatnot. Pressing continue will send the menu selection request back to the restaurant owner. And as we can see, Casey, has menu selection items. Richard can accept these and this will update, actually, the contract. So the third step of the process is to upload a contract agreement, which we have a sample one here. To finalize a reservation, they have to go over the legals and the restaurant will have to upload a contract agreement. Uploading the contract agreement will update the unique link one more time, where the restaurant patron can download, sign, and upload their contract agreement. So we have that prepared right here. So I've submitted my filled out contract. And that should update the link one more time for the restaurant owners. If they accept this, then that will update our reservations and it's complete. Going back to the venue and to the upcoming reservations tab, we can see that my reservation is complete for the restaurant. And that concludes the demo, and I'm going to pass it back to Mari for some final notes.
Thank you, Casey, for walking through the demo. Now I'll be discussing what's next for the project. So what's next for the Ellebit website is that we want to make it more user-friendly. This can be done by creating an administrative interface for both to have access to both the restaurant and patron information. We would also want Ellebit to have a payment functionality so that patrons can securely pay for the information online. Ellebit would also need to give patrons the ability to search for bookable restaurant venues on their website. Ellebit may also want to update their menu upload functionality to allow patrons to upload a PDF version of their menu rather than just an Excel sheet. Ellebit also wants automatic email notification reminders for all three interfaces whenever reservations or changes are made. Overall, the website will need to be more secure to protect customer information and website functionality. As the Ellebit website has a long way to go, the team has prepared handoff materials for the next Ellebit team. This includes our GitHub repository, our master document, which discusses our code and technology, any testing feedback we receive from our sponsors, and our AWS deployment manual. The team feels very lucky to have been a part of Ellebit's journey as we were given the opportunity to build a reservation management system from the ground up. The team has learned a lot from this experience, including communication, teamwork, problem solving, and self-learning. The value of this project for our sponsors is that it has helped them realize their vision of an easy-to-book private dining. As this is just the beginning of Ellebit, we are excited for what its future holds. And we would like to thank our sponsors, Anna and Kathleen, for letting us be part of their journey, and our advisor, Dr. KH, for guiding us through this project and helping us succeed. So thank you. Now we will have time for questions.
Yes, in the back, sorry.
So I guess with the Figma, we started with wireframes where we just made that how we thought the website would look. And then from those wireframes, we turned them into interactive prototypes. So we knew how each page is connected with one another and like where would lead the user. And then after the interactive prototypes, we did a usability testing with our sponsors where they gave us feedback about our Figma design and our prototype, and we implemented those changes. And then from there, we started developing. We were only able to do usability testing with our sponsors as they, Anna is also like a party planner, so she would have liked to use this as well, as this is designed for like party planners as well. So they gave us really helpful feedback. Yeah.
From the crazy 35-step flowchart to the 6-step process, it's a huge simplification. Did you start from there and figure out what the mess of it was, or did the sponsors have the idea of the simplified process that
the sponsors already had the idea of the simplified process, and we just helped designed it for them. But we also had to take away the part where the patrons can search for the restaurants online, as we didn't have enough time for that. So we created the unique link where we could start the reservation process from there. So when the restaurant declines a reservation, they're able to add a note, and that note they can send it to the patron, and the patron will receive that as a notification on their page where it tells them why the restaurant declined it, and it'll give them another ability to refill out the form or remake menu selections and edit their choices. Okay, thank you. Oh.
Yeah.
Oh, that's.
I think we just. Yeah, I can use that one. Yeah. Hello, everybody. We're Team CS 2318. We are Team Postman, sponsored by the Postman. I'll hand it off to Julie to introduce the team.
So this is our team starting from the left. We have Kong Ho, Daniel Vu. I'm Julie Mammon. This is Jonathan Doan and Haley Williamson. And so the sponsor for our project is the Postman, whose owners are Kiana and Devon Jr. Pickett, and our advisor for this project is Dr. Lynn Lee. So let's talk about who exactly the Postman is. So the Postman is a mailbox rental and shipping center based in Central District, and they were founded in 2016 and opened in memory of mail carrier Jacques Chappelle to carry on a family tradition to serve and connect their communities. So let's talk about the opportunity that the Postman presented to our team. So when COVID-19 hit, it impacted the Postman's business with the rising concerns in regards to customer health and safety. So they wanted a way for their customers to be able to still easily access their services and also have a way for their to be able to engage with their customers more personally. And so their solution to this was to create the Postman app in the neighborhood marketplace. Ultimately, what this does is it increases the accessibility and convenience for customers to utilize their services all from the palm of their hand. And now I'll pass it off to Haley to talk about our mission statement.
So our mission is to connect and grow small businesses, entrepreneurs, and individuals together as a community through a mobile application that will provide shipping and business services. This is in line with the Postman's model of keeping communities connected. And so our main goal was to just continue development of this app. For our minimum viable product, there were a number of features we wanted to add. The first is user-managed profile types. So for now, we've implemented buyer and vendor profiles. These profiles are used within the neighborhood marketplace, which allows users to buy and sell products from one another. Our last major feature was to add rating and reviewing to the products in the marketplace so that potential buyers can see what other people have thought of the products before them. Next, I'll pass it off to Kong to talk about our architecture.
Thank you, Haley. So here are our development diagram. So basically, we have a mobile app that display the application layer that have API keys. They will connect to the backend. So the backend will run in the background. So we have all the business logic and maybe need service. And from there, we can connect to the third parties, like we use Firebase authentications or Google Cloud Firebase database, Firestore base. And we also have to connect with the payment methods like PayPal, Apple Pay, things, but we're not implement the payment process this project. So next I will talk about the technologies and tool we are using. So during the project, we choose the Visual Studio Code for our primary code editors. Besides that, we also use the Android Studio and Xcode for our testing developments and run the simulator. In the front end, we use the React Native and TypeScript for the front end. They will support me like a strong type environments. In the backend, we have Node.js and Express.js. They will provide us a robust runtime environments to executing our server-side code. For the remote environment, we choose the GitHub to store our code base and collaborating. The third-party provider we're using for now is Google file-based authentication, since they provide us a simple and a lot of secure authentications. And Google Cloud's the file store database, since they have like a scalable NoSQL database. And we also have a lot of code qualities like chess or pretties. Next one, I will hand this off to Jonathan to talk about our team and Epic.
So, hello. So for the first two, or not first two, during the development of our projects, we've been meeting up with our sponsor and advisors every 2 weeks to keep track of, sorry. So we can keep track of if we're going in the right direction and try and plan what's next for our next sprint so that we are hopefully completing in time. So for some of our epics, it includes like implementing a vendor profile, rating products, a marketplace, and any of our profile managers. So for our next slide, here's some of the stuff that we have accomplished. So for the first thing that we completed was the profile managers, which allows us to create, edit, delete the buyers and vendors profile for each of our users. We also did a complete UI revamp so that it's more aesthetically pleasing to our users. There's also the marketplace where the buyers can go around, shop around the products that the vendors have listed. And there's also, they can also rate and review other vendors and the products that they have bought so that other buyers can see what they see, what they think of. We also improved the error handling so that our app can handle unexpected situations. So like when users put in incorrect information or is missing some information, the app would stop them from going to the next steps. So to allow them to fix that. We also completed the checkout flow so that the users could be able to complete the transaction of their orders. And yeah, I'll pass it off to Dan to finish off.
Cool, thanks, John. I would like to talk about our risk and blockers for this project. There are a couple of blockers that we've had, and this mainly came from mobile development on a React Native. And as many of you guys know or may not know, React Native is a hybrid mobile application platform. So this means that we're developing on both Android and iOS. A major problem with this hybrid platform is that when we develop on one and we create a feature for one, for example, iOS, where we have to first verify that it works on Android. So ensuring that we verify both functionalities was very time consuming and was a blocker in one of our many of our sprints. Another blocker that we had was the lack of documentation from last year's team. We were working on the past 2 years of development, and last year's didn't have any documentations at all. So that really struggled. We really struggled trying to understand the code base and trying to understand where they left off. But other than that, I'm really proud to announce that we can showcase a demo and show you what we've been working on. Cool. So this is the Postman mobile application. Okay, sorry about that. Yeah, so this is the mobile application for the Postman. What you see here is the first thing that opens up when you first open up the app. This is the login page. From here, you can actually sign up, go through this whole flow. There is form validation for every single input fields. In this case, we already have a account for us to log in with. So in this case, it's ea.com and 1, 2, 3, 4, 5, 6. When I log on, we'll be presented to the profile select page. This profile select page is where you're able to manage your profiles. You're able to create profiles. You're also able to edit them. In this case, if you want to create something, you can click the add profile and click on buyer. We already have a buyer profile created, so we don't need to go through that entire flow. We can also edit if we want to by clicking the edit button. Click on this. Awesome. So for this demo purpose, what I would like to showcase is going through the vendor first, and then we'll go to the buyer profile. So as a seller, you can sell products. When you click on the vendor profile, it'll take you to the profile and you can show all of your products there. And you can also see this list of summaries and figure out what you would like. You can scroll through, figure out what products you've already listed. But in this case, let's actually sell something. When we sell something, we want to upload a photo. Pick a random photo that we have, and let's sell some bubble tea. A great bubble tea as its description. Let's have the category as food. Let's make it $6, and let's say we have about 120 of them. When we click list, this is going to send it to the database, and it'll be uploaded in real time. So let's actually go ahead and switch profiles and go to the buyer profile. And from here, this is your buyer profile. You can buy products, you can view the marketplace, see what kind of products there are. In this case, I want to click on the marketplace. And this showcases a beautiful marketplace. You can scroll through it, browse, whatever you would like. If we wanted to look at the product that we just listed, we can go ahead and type in bubble tea. And there we go. That's actually solid bubble tea. In this case, let's try and find a product, Leapfrog. If the title is too long, you can click on it, expand the title, scroll down, look at the reviews, and you can add to cart. When you add to cart, a toast will show up saying that it's been added to the cart. We can go back, click on the cart, and we can go through this whole checkout process. We can check out, and as Colin mentioned before, we don't have any payment in place yet. So we can just skip through all this and have this updated in real time in the database. Cool. So once we've ordered the order, you can go back to your profile and see all of your recently ordered. In this case, you can click on this, and it shows Leapfrog. You can go ahead and review as well. Let's say it's about 4 stars. It was pretty good, but not good enough. And then once you're done with the buyer profile, you can switch profiles, you can sign out, do whatever you would like. In this case, we'll just sign out, bring us back to the sign out page. That's it for this demo. Thank you, everyone. We'll move on to the next slide.
Okay, I can then talk about the lesson we have learned. So throughout the course of the project, we got several key learnings. And one of the more important was the value of working on the separate branch. This helped to manage the code efficiency, prevent the conflict during the merge process, and also ensure the integration of our individual contributions. We also realized the importance of verified functionality on both iOS and Android. That's an essential step for us to test our code platforms on both iOS and Android to ensure the consistency of the user experience. And the last one, we also learned about the discussions about story dependencies. By understanding how our tasks interconnected, we are able to better plan our work and also mitigate all the potential roadblocks. That's also our essential part of our project's management strategies and greatly influence us to our ability to deliver our project on time. So next I will hand this back to Daniel and talk about what next with our project.
Thanks, Kong. There are a couple of things that's left for this project that we haven't been able to complete due to the time that we had. One of the main major features that we want to implement was a messaging feature. So we want vendors and buyers to communicate with each other and talk about their own products. Another thing that we want to implement is payment, as we discussed before. Payment is a major feature within a marketplace. If you don't have, payments, then it's not really a marketplace. Another thing is increased security. A lot of the APIs that we created and developed within the backend server, they're all open to the public. This is a huge security issue, and we want to make sure that we secure that and make sure that no data is being leaked out. Other than that, I would like to thank our sponsor, Kiana. She's right here with us today, and she's been really helpful. She guided us through this project and showed us her vision of what the Postman really is. So we're really grateful for you. Thank you so much. Another one that we would like to thank you is Dr. Lee. Dr. Lee has been an important and integral part of this project. She has attended every single ceremony that we had, and as well as ensuring that we were on task, on time. So thank you so much. And overall, thank you everyone for being here tonight. We appreciate your time, and we'll open up for questions. Our question.
Yeah, so you mentioned that one of the blocks you didn't have any documentation on our team. What specific kind of documentation and what do you have planned? What are the things that you would have liked to see from the prior team?
Yeah, of course. I guess one documentation that I would like is seeing what the design doc was, what the scope document was, what they envisioned, and what tasks they had. Because we didn't really know what they started with and we don't know what they ended with, it was really hard for us to figure out, okay, we need to pick up what they left off, but it's hard to pick up what they left off. We don't know what they left off. Yeah, Sidority.
So what kind of automated testing did you do for the project?
We don't have any automated testing. We just have unit tests. One thing that I would like to implement is integration tests to ensure all the UI is working for both Android and iOS. If we're able to do that, we'll definitely increase the speed of development that we had. Yeah.
So your unit tests are automated?
Those are, by automated, you mean like automated on a pipeline?
No. So just you written code test the exercise.
Oh, yes, yes. You can manually run them. Yeah. Yeah. Yeah, fun fact, Doherty did help us with the UI. We were under as a UX professor. And so the first iteration was through him. Yeah, through Figma. Any other questions? Yeah. We went through with Kiana. So every major feature that we have, we tested it with Kiana, got her feedback. And every time she had a suggestion, we would run it back with the team, and that was it with the sponsor and I. We didn't have a large user that we could give out to. It was just mainly amongst the team. All right. If there's no more questions, yeah, go ahead.
I saw just in your
Yeah. Yeah, we did. Yeah, so for React comes with Jest. So we did unit testing with Jest in React. Another thing, the library that we implemented was React Testing Library, which is, if you guys are familiar with it, it's another component. It's better than Enzyme. Enzyme is deprecated now, but React Testing Library is definitely with Jest. It's definitely up there with me. That's what we've been testing with. Yeah, we did. We also used Jest as well. So with that, I believe we achieved about 90% test coverage. Cool. If that's it, then thank you everyone for being here. We appreciate it.
Well,
No, we're still after the year. You can be there.
I think at the mute. Because if not, then I don't think you can connect. We have two connections. Wait, 1 second. Also.
What is the meeting?
Yeah.
Where is that?
Yeah.
Just walk.
This one's a ring that tracks my reality. Heart rate, so since my mom. I forget where I got it. Found this.
Yeah.
Good.
Wait, do they not take, I think this works.
Yeah.
Should we try it?
I think this one works. Hello, so it works.
Yeah. Need the meeting pass. You have the passcode?
No,
Meeting passcode.
Okay, try 220.
220.
475.
Do we need to record it?
Okay.
Join and then mute it.
Everything's ready?
How many faculty?
How many what?
Faculties.
I don't know.
There's
Whoever,
only.
whoever wants to come.
Did you get it?
Yeah.
Well, it's just not like all.
It has this adapter, right? The HDMI.
Then when we're presenting, it didn't have to do.
Hmm.
Whatever, okay.
You can
got it.
present for us. We have to test it.
Do we have to use the mic?
Testing. It's not on. Is it?
I think it was. It's red.
Hello. Hello.
I think it's
Hello.
It is.
Hello.
It is.
Yeah.
It is. It is.
Hey, turn it off. Oh, huh? Wait, are you? Oh, yeah. You say that.
Wow. Congratulations.
Oh, bye.
Yeah.
She's like, I don't like it.
Yeah.
There's the camera somewhere here. Do you want to go to the center or brother?
Oh, yeah, for sure.
Go on the other side.
Everyone's super excited and just flooding in for our presentation.
Testing. Hello. Hello.
Hola. Are you excited?
I mean, I already know.
You nervous?
They
really have
have
some of it?
and with the sponsor.
It was good.
It was on Zoom.
Yeah.
It was on there and presented on Zoom.
Okay.
It was ridiculous.
Only like.
How do you mute
Nick was
this?
Huh?
Only Nick was this.
Hello.
Yeah.
Yeah, it was only Nick, and then got into the conference room and Nick like zoomed us in the TV into everyone else. So there's like 3 other people, Kendall, Nick, and David.
Not as far as last time.
Yeah, we just sit there.
Yeah, good thing you didn't go.
Yeah. Very fast. You would have been like wasted time.
It's possible. We have one with the 4 participants.
Maybe because it's at the end of the day.
Yes, I know.
Fine by me.
Save the best for the last. Fine for me.
Or if I have something myself sitting down here.
That's okay.
I went to the food. First, the food over there. What do they have?
They're serving drinks too. So they have free pizza, free beer and stuff for you. They always have those cakes. You get cakes now.
Have any drinks there? What was?
Someone was just saying that.
They have a coffee downstairs.
Free beer and pizza. That's what someone was saying. No, here. Yeah, but that's just the word on the street. Like, don't take anything I'm saying for. That's just hearsay. So. Yeah, let us know too. I was too young. Yes, I can't get in the bar. It's okay. That's right. Sit on stage. Could you please sit here? Give us some comfort there.
You don't need.
Or you can help us click the PowerPoint that's you. Let's do the race.
Did it sing? That's very inconsistent. For the same footprint. Tell the other teams.
I'm doing the product.
Give the mic too.
Yeah, give to me. I get to try and give it.
I'm sure you can tell me after the other one.
Just after the problem.
The timeline.
How long does this take? Yeah. Fast up. Only like 30 minutes.
I'm like, how will get it to you? You keep telling me to get back.
Every time.
Yeah.
What is this name?
Yeah, and then I give it to Trey. Trey does everything. I do the last one. Yeah, both times. Give up to you.
Making it easy on me, Andrea.
Where's my other one? Down.
That one and this one. The executive one. And then you just stress how important it is for customers. But you can just quote tour.
I forgot. It's on there.
No, it's not 1 minute.
Start in 1 minute. Is the intro? Yeah. Make sure you turn it. Yeah. This slide.
Are we ready? Can everybody hear me? All right. Thank you all for coming to our presentation about early warning sentiment analysis and F5. My name is Torrin Freever. These are my group mates. Hold on, Walt.
Trey Hammer.
Andrea Lee.
Our sponsor is wonderfully right here with us, Dr. Zin Zhao. Big shout out to him. And our two sponsors for the project we were in constant contact with were Kendall Bernice and Nick Ferguson. Okay, so a little bit of background on F5 as a company. F5 is a large-scale network security company who has, again, large-scale clients like Microsoft, Tesla, Meta, as well as the city of Seattle. Due to the fact that they have such large-scale clients, they have many, many customers who use their products very frequently. These customers obviously have a lot of questions about the products and a lot of feedback to give to F5. So F5 has a strong focus on customer service and the importance of customer satisfaction within their company. So this project was created in light of the fact that F5 is aware of one serious business factor, that the customer is king. So the idea behind this project is that when a customer sends an email or some sort of notification into an F5 customer support service base, this email will be sent through machine learning models and analyzed for sentiment being negative, positive, or neutral. That sentiment will be displayed for an F5 customer support agent to view and to be able to handle these customer support cases as they see fit. So again, the idea is to use Salesforce to access customer data and to have access to Einstein AI, which is the machine learning model that we use to analyze for sentiment. The machine learning model, we'll go into more details later, but it uses keywords to be able to identify sentiment. On to Andrea.
So for our final product, what we have created is that when an email enters into the Salesforce database, our machine learning model automatically analyzes for the sentiment and categorizes it into positive, negative, or neutral. And then our second component that we've created are the visual force pages. So the web pages that the customer
service support engineer will see once they enter into the Salesforce database to use. And the sentiment will be displayed in tables and graphs that you will later see in our demo. We have 5 different views that you will be able, the service support engineer will be able to see. So the first one is an individual case. So for an individual person who is contacting our service support, and then the customer contact, which and then accounts, which consist of many customer contacts, all incoming emails generally, and then we also have an error viewing page. Our last 2 components that we have is, say if there's a false positive or a false negative with the machine learning model, you will be able to edit the sentiment to correct it. And then our last is to generate a PDF report that workers at F5 will be able to use for their meetings if needed.
So I'm going to be doing a brief introduction on our architecture. So as you guys know, our architecture is mainly based on Salesforce. And so it all comes down with the customer. They can email the F5 support email, which will create a case. And whenever an email comes in, we used a database trigger that will basically send the email data to the Einstein model. And once we retrieve these results, we mark the sentiment. And so whenever a support engineer comes along and wants to see the sentiment results, they'll come access our Visualforce page right here. And as Andrea stated, we have 3 views. We have one view that lets you view a specific case, a specific contact, or a specific account. And then we have another view that will let you analyze the sentiment for the entire Salesforce organization. So that encompasses all customers. And then finally, like we said, the PDF generation report, which is used for the weekly analysis. So on to Hal for our ERD diagram.
Thanks for Trey. So right now we are talking about the ERD diagram. So we've been talking about the cases, contact, and the email messages. So basically all the emails will create a big class cases, and those cases will contain some metadata like key points, like case numbers. And each cases will has only one corresponding contact which contain those informations, how you can call those customers. And each cases will have may or may not have multiple email messages. And those email messages will contain the main body of the emails and also the sentiment analysis results. Could you move to the next one? So this one is a breaking down of the UML diagram. So we have the sentiment analysis batch. So the data we've been collected is like messy. We need to modify by the sentiment analysis batch. And then we pass to the sentiment analyzer, which is using the machine learning model to get those data and analyze. Then we got the sentiment results. Those results are really important, and we feed to the generic sentiment controller. This controller is a controller to all the front pages. We have all view pages, we have single view pages, and those will initialize the data for the different visualizations, such as the pie chart or the line chart or distributions, etc. And then we comes to different pages. Next one, please. So this one is the development environment. So we are F5 sponsored, and everything we use is based on the F5 platform, which is a Salesforce platform. We use a sandbox, we use Lightning components, and the machine learning model, which is located in the Salesforce Einstein platform service. So we're using that also. And for our code, we import the simple Salesforce, which is a Python library. All right, just a quick overview of the brief timeline that we went through for this project. The fall quarter, October through December, we were planning, documenting, creating, a plan for how we were going to implement this project and in communication with our sponsor. The winter quarter was when the massive majority of our development occurred. This was January through March. We had weekly meetings with our sponsor, and we grinded out the bulk of the project. And then finally in spring, April through June, we were mostly focused on a little bit of those last couple of features, as well as development testing. And then just a few days ago, we presented the full product to F5, and yeah, essentially was our product launch.
So for our major milestones and accomplishments that we achieved this quarter, as talked about by Trey and Hal. So our first one was retrieving the sentiment analysis through our implemented machine learning model. And we calculated the F1 score, which shows how accurate the machine learning model is. Our second is the sentiment analysis. So how we submitted and sent in the emails into Salesforce and had it analyzed by the machine learning model. Our third achievement is the visual force pages. So being able to display our results to be seen on the visual force page. Our fourth one was displaying our different views that I described earlier. Our fifth one was the automated report. So being able to generate that PDF for the weekly meetings that F5 will have. And the last one is the extensible documentation. So allowing F5 to be able to implement our code into their Salesforce database.
So I'm going to be going over some major technology blockers. So one of the unfortunate things that happened was that we couldn't get the actual data from F5 due to regulations on how they could use the customer data. So we were limited to a Twitter data set. So this is very important to our project because the accuracy of our model doesn't reflect to different data sets such as theirs. So that's pretty much the blockers. So now we're going to be going over a quick demo.
All right, time to put the money where the mouth is and show you guys our product. So this is the Salesforce dashboard, and this is the sandbox environment that we're referring to. What Trey is doing is pretending to be a customer support staff engineer for F5. And right now he is viewing a single case. So the case again is created when customers send in emails to F5, and Trey is looking at some of the graphs that we have generated for the customer support agent. This shows, the one that he's currently looking at shows the sentiment over time. So a case can, accumulate many emails, and these emails all have an associated sentiment. And so then we display the sentiment over time of the incoming emails for this case. This is the distribution chart for this particular case and the emails that have been associated with it. So you can see the percentages of how many emails were associated with what type of sentiment. Going a little bit further, you actually can see all of the emails sent in. Trey was the one sending these emails. So these are his, and you can see the associated sentiment in the middle column, the date the email was sent, and the actual message of the email. Now say that one of the messages, you believe the sentiment was analyzed incorrectly. You can edit, Trey, just click the edit button, and you can edit the sentiment of any particular email message. And then when you save it, it updates that way. F5 can be accurate on how their sentiment is being received. So yeah, next Trey is going to the all view sentiment page. This is more of a higher level view of all of the emails that have come in to F5 and their sentiment. Bear with us a moment. Salesforce sometimes takes a while to load, and it's loading a decent amount of data. There it is. So this is useful to Salesforce or to F5 because they're able to see how satisfied their customers are directly with this data. They can say, oh, this, for the past year, we've had 38% positive sentiment. And this is, data that they can share with potential clients. This is the view page for accounts, and you can also look at contacts. This is just different ways of filtering through the types of client you want to see the sentiment for. And then this final piece here is the PDF report. So if they so choose, they can download a PDF report, and it'll list out all the accounts associated with the PDF report. PDF report in Salesforce, you can't actually generate graphical data, so you just have to show it like this. And there's only one account right now that is associated in the sandbox, which is Trey, so that's why there's only one account. But it shows the account ID, and the
associated sentiment with this account. So yeah, that's pretty much pull down all the products.
So I'm going to talk about the value of the project. So based on our first presentation, these were some of the statements that they made during our meeting with the executives. They were very pleased with the product, and we had a engaging discussion with the execs on how they would actually implement this product. One of them was, you may have unknowingly given a technique for automating a weekly manager's account review. And this was a feature that we didn't already have implemented, and we showed you in the demo. That was the PDF report. So we sparked some conversation with the execs. And another quote was, the level of engagement and ideas that came from the audience are a testament to how well structured this presentation and use case is. So they're very happy with our presentation and excited to implement the product once they hopefully get the data.
So for what's next, the remaining little bit of time that we have left. So the first part is turning over our code over to our sponsors at F5. And so we're currently in the process of uploading our code into Azure. And then the last part is implementation. So hopefully F5 will be able to use the extensible documentation that we created for them to be able to implement our code into their Salesforce database to use. And thank you. So we just wanted to give a special thank you to our sponsors and our advisor. Do we have any questions? Okay.
It sounds like, so you're including
So yeah, all the data is in a sandbox right now, and they were trying to request access to the data, but there's been a lot of legal issues with that, and they're really making it a hard time. But the execs were like trying to fight for our project. So.
Yeah, you're essentially correct. We haven't fed our model on our code the actual customer data because basically their lawyers said no. So we weren't able to do that. But they did recently, after our last presentation, say that because of how useful they believe our project to be, they presented a solution similar to Salesforce itself as an organization, and Salesforce essentially said, oh yeah, okay, we're going to make probably a product very similar to this. So they're going to probably launch something similar in the future.
How do you believe that your product can be on and potentially even expand the product with projects?
So one thing for sure is to improve our product would be to use a more responsive user interface. Right now we're using Salesforce and it's very unresponsive. The page loading time takes about like 3 seconds. So that could be a pain point for the engineers. As far as integrating with other projects, I'm not exactly sure, but our sponsor did say that they could use it to analyze the performance of their support engineers. So if they have like a customer that has trending negative sentiment, they could evaluate this particular support engineer that has been handling these customers and give them the proper, I guess, training or consequences.
Yeah. I mean, knowing how your customer is feeling is extremely pertinent in any business sense, right? So being able to take that information and do with it what you want is extremely important for any business. The only other thing that I could think of, and maybe you could elaborate if anyone here,
using a different machine learning model because we were restricted to using the one that was on Salesforce, which is the Einstein AI. We aren't 100% sure if, maybe there'll be improvements in AI in the very near future that would allow a more accurate model that would, give more accurate results on set. So that could be extensible work.
Right. Thank you all for listening to our presentation.
We're gonna go.
Everything around. I just. I don't want to turn that off without a. I don't want to turn that off and cause everything to. It's this way. What are you trying to do? That. Oh, you need to go. No, I got it. Pulling up here. Go off that side. Not enough things have gone wrong. This is probably going to open on the wrong display. Yes, it did. Okay. Cool. I think we're ready to go. Oh, no, except for that. Yes. Yep. Cool. All right. Now we can get started.
All right, does this work? Yeah, I have to.
Yeah, we just have to turn. No, I muted it here, so we just need to turn, is it podium? No, that's this one, wireless.
Hello, hello? We don't really need it anyway. It's whatever. Alright. Hello, everyone. We are group CS 2309 and our project is F5's Rapidlab V2. I'm Colson Wong. I'm Brandon Wong.
I'm Samuel Monson.
I'm Rucha Zoshi.
And I'm Matt, calm down.
Okay, so we just introduced ourselves, but our team also consists of our two F5 sponsors who are Josh Rose and Daniel Brogan. Josh is the senior lab DevOps engineer and Daniel is the senior enterprise network engineer. And we have a faculty advisor from Seattle University who is Matthew Thayer. So a little bit about our sponsor who is F5. F5 is a cloud management and security company that is located and headquartered here in Seattle, Washington. They offer many products to their customers such as management services and all-in-one hardware plus software solutions and many more. So F5 protects over 4.5 billion web transactions every day and is trusted by 85% of the Fortune 500. And at F5, they have what they call technical support engineers, or TSEs for short. And what they do is they help diagnose F5's own customer issues within the customer's technology stack. And so to assist F5 TSEs with their work, F5 has developed an internal application called Rapidlab. And Rapidlab is just a tool aimed at the TSE to enable greater support to the customer. And real quick, before we get into talking about the project technically, I want to talk about what it has been like working for F5. And it's just been an amazing experience, being able to work on a live project. And, they've been very helpful and welcoming and very good at helping develop our technical skills. So I just want to thank them for that, and we really appreciate this all. And now let's get on to talking about the project. So the current implementation of Rapidlab, or I guess you could say the problem of it right now, is that it works on multiple disparate systems. And also it operates off of VMware. And F5 wants to consolidate these systems onto a single platform and switch off of using VMware. And there's also a need to enhance the technical support engineer workflow. And now I'll pass it off to Brandon, who will talk about our solution.
Thanks, Olson. So as he mentioned, the solution for this project is to re-implement Rapidlab V1 into Rapidlab V2, which focuses on improving the scalability and workflows for the technical support engineers. As you can see in that diagram, we are going to be within each data center. There's the red middleware, which is what our project is going to be focusing on. In order to support these technical support engineers in their task of resolving customer issues, we'll be replicating customers' infrastructures within a sandbox environment. And in order to do that, we'll be transitioning the backend from VMware to OpenShift. This aims to save F5 some money as well as giving technical support engineers some more advanced features. And yeah, next slide. So a little bit about OpenShift. OpenShift is a commercial container platform by Red Hat, who is a hybrid cloud and IT company. What really matters here is that OpenShift allows us to use the VMs, and it supports VMs through an extension. And this is going to be the platform our team will be using to execute our operations. Before we go on to talk about the technical details of our project, let's go over some terminology that we'll be using throughout this presentation. First, an OpenShift project is also known as a workspace, which is a replication of a customer's environment within OpenShift. Some things that can be within a project include virtual machines and networks. Next, a virtual machine is a computer emulated in software, and we will be shortening this to VM. And lastly, our targeted users for our software is the technical support engineers, and we'll be shortening that to TSEs. So on a high level, our project looks a little something like this. At the top, you can see a red box, which is the main directory our work will be done in, which is the GS Labs Python library. Our main deliverables for our projects is outlined here in the blue boxes, which is OpenShift project creation. project deletion, and virtual machine operations. Lastly, all the green boxes will be our major methods that are needed to accomplish these major deliverables. And as you can see, these green methods are targeted in order to translate every action in Rapidlab to actions in OpenShift. So for example, if a user wanted to create a project, it would go through our middleware, and then in the end, it will create a project in OpenShift. And now I'll pass it off to Max, who will go more in depth about our major deliverables.
Thanks, Brandon. Yep. So when we sat down in the fall with Josh and Daniel, the sponsors, they kind of asked us what part of the project we wanted to work on. They give us a good amount of feedback. And it was the front end, middle, or back end. And we all kind of said that we had all worked in front end, done a little bit of front end here and there. So we all wanted to focus more on the middle end. Is that cool? Front end, is that out of scope? And they came back a little bit later with a set of major deliverables, a series of tasks below each of them. So these three main deliverables would be project creation, project deletion, and then the virtual machine operations themselves. Under each of these, there were a few tasks that they had been noted. Each of these tasks roughly translated directly to a method. There's like utilities and helpers, and a little bit more, but it's more or less that. On top of this, each one of these tasks, we're going to require back-end routing using Flask and documentation from Swagger. Swagger is an open source tool used for documenting APIs. It's where all our Flask routes are documented. When we had originally planned developing, we thought we could kind of handle everything in an iterative fashion. We would start off finishing up everything from project creation before moving on to project deletion. Within the first week of development in the winter, we realized that wasn't going to work. Too many things depended on other things. Like we had to finish some of the virtual machine operations just to get project deletion done. So we just kind of handled everything consecutively, like all kind of top down all at the same time. And since we were in constant communication with Josh, like at this one project, we meet twice a week, we're just able to test immediately with the meeting. Now I'll talk a little bit about the interaction between the components from a higher level. So basically, you have the Django front end, Flask middleware, and the OpenShift backend. So the front end, like I mentioned, is completely out of scope for us. Later on in the presentation, when we show our demo, we'll be calling all our methods using the basic scripts that we put directly into the command line. Front end isn't ready yet, it's not quite ready. So from the user perspective, when a support engineer shows up and starts using this project, they interact with the front end. They use the front end to make a series of calls. And these calls then get routed through Flask's middleware into the OpenShift's back end where the bulk of our project resides. Once the correct OpenShift methods are called, it'll be able to open up to start a virtual machine that contains the customer's own workspace configuration. And using that, they'll be able to emulate the customer's environment, network environment, and be able to solve problems. The dev environment was relatively straightforward. F5 provided us the laptops, so we could have their machines to program on every time we were doing anything. We used their own VPN that was connected to their own brand IP anytime we were on the machines. As far as IDEs, VS Code was relatively lightweight, so we still use that. We weren't compiling on our local machines. We were using GitLab, which allowed us to have access to their own GitHub repository as well as running our code on their pipelines. Pretty cool watching the linker run for 10 minutes at a time. Everything was developed in Python, and of course, we're using OpenShift to implement this into the Python method. And next, I'll pass it on to Sam, and we'll get into the use case demo.
Thanks, Max. Our demo will consist of an example scenario where an F5 customer is having problems running their application between two F5 products. A F5 technical support engineer will replicate the customer's configuration in Rapidlab to test the application. To replicate the customer's infrastructure, the TSC will perform the following steps. They will create an OpenShift project. They will create a network attachment definition, which is an object that allows VMs to communicate into internal F5 networks. They will create some virtual machines. Then they will test the application on the virtual machines. And finally, they will clean up the project. We'll go into the demo. A quick disclaimer before we begin, and Max kind of touched on this. The GSLab user interface has not yet been wired up to user routes as it's outside the scope of our student project. For that reason, we will be invoking the routes manually in a command line. Just keep in mind that these actions would be handled by a UI in the final product. On the right, we currently have the Swagger API page for GSLab. This documents all the API routes inside the Rapidlab Flask container. Routes beginning with V1 OpenShift are the ones created by our student team. We will start by making a call to this project route, and you can see in the Swagger page that this route takes a name of the project and a project owner. So in our terminal on the left, I will go ahead and paste in a command that invokes this route. This route.sh at the beginning here is just a simple wrapper around curl. If you're familiar with curl, that just, abstracts away some of the miscellaneous details. On the right, I'm going to go navigate over to the backends UI. This is a built-in UI for OpenShift. We're just going to be using this to show the results of our routes. For this invocation, we can see that we're giving it a name of S-Monson demo and a owner of S-Monson. And the current user in our OpenShift UI is currently S-Monson. We can see we're on the projects page, and you can see a couple pre-existing projects here. So I can go ahead and run that route, and you'll see a new project has been created called S-Monson demo. We can now start creating things within that project. So the first thing we will do is create a network attachment definition. And I will paste in the route for that here. We will call this one DemoNAD and give it a couple details that are required for a network attachment definition. And before I run this, I'm going to navigate over to the section of the OpenShift UI that shows these and go to our current project. So now we are seeing the network attachment definitions inside our project. And then I will run the route. And you will see that we've created a network attachment called DemoNAD. Next, we will run a route to create a couple of VMs. So I will head back here and paste in a call to the project S-Monson demo VM route. We're going to be calling these in a loop so that we get two VMs, demo VM1 and demo VM2, as subs in for the name. We'll set their state to false. This will cause the VMs to be created in a shutdown state. We'll give them each a initial password of test pass. Give this template as the initial the template for the specifications of the VM, and then tell it to attach that DemoNAD to each of the VMs. So in the OpenShift UI, I go navigate to the virtual machine section, and then go ahead and run this route. And you'll see that we've created two virtual machines. We click on one of them. We can see some details about the virtual machines, such as their current status and their resource allocations and a few other details. We go over to this network interfaces tab. We can see that a network interface has been created that points to our DemoNAD. Next, let's start the VMs, and we will do that by invoking yet another route. We'll copy in here. This is a patch route that points to each of the VMs. We will flip the state to true, which will have the effect of starting the VMs. So I'll navigate back to the VMs page and run this. And you'll see each of the VMs is now starting. We can navigate over to a second panel in our terminal and connect to the console of each VM. And in a moment, we should see, go. Internet's a little slower here. We should see the VM starting up. This will take a few seconds, not that long. There we go. So now that the VMs are starting up, we can log in with the default user for this template, which is Ubuntu. And our password is that password we set before, test pass. Likewise for the lower one, I can click without middle clicking. There we go. I will quickly configure the network interface that NAT is attached to on each of the VMs because by default it's not configured. So I'll just go to this one, configure that. Go to the other one and configure that. And now we can run a server application on the lower VM and a client application on the upper VM. And we can see that they are able to communicate. They are also communicating over a virtual LAN with a bunch of our sponsors' other machines on it. So we could additionally communicate with one of those machines to pull information from it. So here we'll just communicate with another machine on this LAN. If I can paste right. There we go. And yeah, you can see that our sponsor set up a little VM that gives us a little basic web page. So now once we are done working on our VMs, we can go ahead and invoke another route to get rid of everything. So we will queue up this delete route, which deletes the project SMOS demo. So if I navigate back to the project section here and run this route, you will see that this project is now being deleted. If I go back to the VMs, you'll see they're powering down. And once they power off, they will be deleted. And so now we're all done. We've cleared up all of the things we made during the demo. So to quickly recap, we created a project. We created a network attachment definition in that project, created some virtual machines in that project, started those virtual machines, tested a customer's application on the virtual machines, and finally just cleaned up the project. Next, I'll pass the floor to Rucha, who will close out our presentation.
Thanks, Sam. So as stated earlier, we worked on the backend of RapidLab V2 in Python. So our first set of methods that we did was to work on project methods. So this is creating a project, deleting a project, and assigning a user as owner of a project. Our second set of methods in the Python library was related to the virtual machine. So we had creating a virtual machine from a template, deleting a virtual machine, as well as virtual machine operations such as powering on and off a virtual machine. Our second major deliverable, which we worked on from the second half of winter quarter to the start of spring quarter, was doing documentation, which Sam demonstrated with the class APIs. So we basically made sure that all of our methods that we created were documented so that they show on the API that were able to be tested and ran. After this, we completed our major deliverables. We spent the rest of our spring quarter working on one of our stretch goals, which was unit testing to achieve code coverage. So our goal for this unit testing was to get to 50% code coverage, and we were able to accomplish 81% code coverage with our unit tests by the end of spring quarter. So we all wanted to work in backend, but some of the platforms that we were using were a little unclear, especially in that. So working together, especially in the first half of the project, was very essential. However, we had a lot of time constraints because of conflicting schedules outside of college activities that just kind of made it hard to meet frequently. So we realized quickly that working asynchronously once those first methods that really helped us understand were done was the best way to go, and meeting with the team to work on bugs whenever we could, as well as whoever kind of had the most compatible schedules working together together to make that be completed faster was just kind of the way we ended up doing things from winter to spring quarter. And by doing this, we were able to get our major deliverables done as well as the amount of coverage that we did get for our stretch goal of custom. So after this, so F5 will be continuing to work on the MVP as stated earlier, since we are doing front end, the engineers are currently working on the front end. So after we pass off the back end, this will be completed. Thank you. Any questions?
Question.
Cool.
Are any plan on doing this way or let's do that? It's early, we said it's really flexible.